Hello and welcome to another SuperNEC Basics Help video where I'm going to be working with the output interface once again, and specifically the 2D radiation pattern viewer. In front of me right now I have a basic 2D radiation pattern. So once again, as was the case with the 3D radiation pattern viewer, this allows for rapid visualization of a specific radiation pattern in the 2D plane. And I'll be explaining the features of it right now. As was the case with the 3D radiation pattern viewer video, you can watch that later, we're going to begin by going into the component selection. So if you go onto the view menu, you'll see you can select from 3 components: the major vertical, the minor horizontal, and the total components. Currently the radiation pattern viewers on both of them, 3D and 2D, cannot differentiate between the electric and magnetic fields, or the major and minor, or the vertical and horizontal components. Possibly we'll add that in the future. For now, let me just show you. So go up to View, select Major Vertical, View, Minor Horizontal, lastly View, Total, and we're back where we started. There are obviously a lot of similarities between the 2D and the 3D radiation pattern viewer. Once again, you can go to the coordinate axis and select from the 3 options rectangular, polar, and ground in the View menu. View, rectangular. Rectangular is going to be a representation of phi or theta, depending how you define it, along the x-axis, and then you'll have your antenna gain along the z-axis. Next one, polar. As the name suggests, these are now polar coordinates. As was the case with 3D again, each coordinate has a defined gain scaled so that the lowest value is 0 length. So the last one is quite interesting when you select the ground view on this 2D radiation pattern viewer, because the pattern below ground level will not be displayed, because if you'll recall from our 3D radiation pattern viewer, we're only displaying the parts that are above ground, in other words, z-axis and upwards. So this is only going to be available for elevation plots. I've added an important disclaimer at the top here, just for clarification. So these different plot types, our data is the same. It's been the same the whole time. We haven't changed our assemblies. So rather than thinking of it as different plots, it's better to think of it as different views of the same data. So if you're going to be changing anything about this limits technox, grid visibility, as I've mentioned there, it's going to be applying to all views that we just mentioned, not just the current view. Next, we'll be moving on to the options menu. We can explore stuff like the limits on angles, magnitude, tick marks, grid, magnitude units, labels, and the origin placement of polar plots. So let's begin with that. First things first is changing up the labels of your plot. So you can click directly on the labels, or you can go up to the corresponding sub-menu. So you go Options, Labels, and once you've finished changing your label name, you can just simply escape and you've changed it to what you want it to be. Options, down to Labels over there, Title, and yeah, there it is, Radiation Pattern, Azimuth, edit it as you like. If you're using this for a project or a presentation or something like that, you need to note that labels will just reset to its default one if you change your plot view. So if you're going to be taking pictures or screenshots of this, please keep it in mind. The next thing is the units of measurement. So it's common scientific practice to display the units on any graph you're representing. So we're going to go up to our options menu again. And I'll show you now. The first thing you can select from is dBi, which is the default setting, because that's sort of the normal unit of measurement for gain and such. Options, units, you can select from dBi, dB. So basically what you're going to be doing is you're going to be converting your dBi so that it has a maximum magnitude of 0. So that's normalized decibels. Next one we can use is dBd. dBd is basically defined as a dipole decibel, which is going to be defined as your normal dBi minus 2.14 dBs. Note that for our current plot you might actually not be seeing the normalized dBs, but for any other assembly it should show up fine. Another little cool feature is that you can actually add markers to your plot at specific points if those data points are significant to you. So let's begin. So basically you're just going to start by using your left mouse button on the line you wish to add the marker to, and there's no limit to the number of markers you can add. So eventually the legend might get a little too large, but if you want to make a marker legend, you can just go to the View Marker menu. So just click over there, add a marker, marker 1, 2, and now we can just go markers. So you'll see once we've actually added the marker legend, we have the exact value of our markers at that point. So if you want to move your marker to see the value at a separate point, you can use the left mouse button and just sort of drag it to where you want it to be. And then the new data marker will appear where you've dragged it to. I'll just show you, drag marker 1 over there. You can see down there in the legend that our values have changed and we now have the values of the new point displayed. So if you want to remove a marker, it's pretty simple. Do the opposite of what you did before, right mouse button, and it'll just disappear. And the other one will also be renumbered to the appropriate value. Boop. Marker 1's gone, marker 2 has been relabeled. Next thing I want to draw your attention to, I'm sure you've noticed this thing labeled structure right here. So if you pass the structure into your 2D RadPad viewer, then it's going to be displayed on the right here. So usually it's also the space used to display the legend. Go up to the View menu, click Legend. So you can choose to see the structure, but you can also turn it off if you go up to the View and onto the structure. So currently, in this version of SuperNEC, you cannot resize the legend or the structure view, but we'll see what we can do about that later, hopefully. So let's just do that quickly. View, legend, there it is. And I think that's pretty much all I need to show you right now about the 2D radiation pattern, and I'll see you in the next video. Have a great day.